Hi there, welcome to this video. It is designed for Year 13 pupils studying Maths A-Level, Daily Maths 9, time for your pure stats and mechanics to shine. So here we go with Daily Maths 9 for the 6th of January. We have got the volume of a sphere with radius r increasing at a constant rate of 3. So whenever we see the word rate, something is changing with respect to time. So we can say it's dt. Now what is changing? It is the volume. So that's going to be dv by dt is equal to 3. Now being asked to find the rate at which the surface area of the sphere is increasing when r is 10. So this is a connected rate of change question and we need some connecting formulae. Now we've got v in this question. The volume of a sphere is 4/3 pi r cubed. The surface area of a sphere is 4 pi r squared. Now what we're after is the rate at which the surface area, so we actually want ds by dt. Now we need to make a chain, and in this situation it's going to be a chain of 3. Now we always start our chain with what we want on the top, which is ds, and we need to end our chain with what we want on the bottom, which is dt. Now what can we use to connect these two? From this s equation we can get ds by dr, so we can have a dr there. Now we need to keep the ds but have something to cancel with the dr. So on the top we can have dr by dv. And we can get that from this v equation if we do dv by dr, and then we'll have to put it in upside down to get dr by dv. And then what we're given in the question, which is dv by dt, so we can have that on the end. Now these ds by drs, dr by dv and dv by dt, they're not fractions, but if we put what stands for each of these, then effectively the dr's top and bottom can cancel, the dv's top and bottom can cancel, and we'll just be left with what we want, which is ds by dt. Okay, so let's put in what is ds by dr. Differentiating 4 pi r squared is equal to 8 pi r. So that's 8 pi r there. What is dv by dr? It is going to be power down, which will cancel there. It's just going to be 4 pi r squared. But we need to put it upside down because we actually want dr by dv. So that's 4 pi r squared there. And then timesing by 3. So let's cancel the pi's top and bottom. The 8 and the 4 will just leave us 2. The r and r on the bottom. So what have we got? We've got 2 times 3, which is 6 over r. And it's asking us for when r is 10. So let's put 10 there. So overall, we've got 0.6, and that will be centimeters squared per second. Now next one, we've got the air pressure P inside a tyre after the tyre's got a puncture is this equation here. We're being asked for the rate at which the air pressure in the tyre is decreasing 2 minutes after the instant it has a puncture. So again, we're seeing the word rate, so we need to do dP by dt. So differentiating, the 0.8 will go out. When we differentiate e, it's the one function that differentiates to itself, but then using the chain rule, we'll have to differentiate with respect to the inside function, so that'll come down and times by the 1.4. So a half times 1.4 is going to be 0.7, and it's minus a half, so it's minus 0.7 e to the minus 0.5 t. Now all we need to do is put in that t is 2. So if we do that on our calculators, it comes out to 3 significant figures to be 0.258. Now what we're measuring, pressure, which is kilograms per centimetre squared, and because we've done dt, it's going to be per minute. Here's the next set of pure questions. We've got f of x is this equation here. It has a single turning point at x equals to alpha. Show that alpha is the solution of this cubic here. So to find turning points, we need to set the derivative equal to 0. We're in function notation, so we need to be doing f dash x. Differentiating the first term, we'll get 2x. Now, if y is equal to the ln of x, then dy by dx is equal to 1 over x. We've got here ln of this function. So a function of a function, we differentiate that using the chain rule. We differentiate with respect to the outside. So ln differentiates like this. So it will be plus 1 over the 2x squared minus 4x plus 5 because we leave alone on the inside. Then because we've not differentiated with respect to the inside, we then must multiply it by 4x minus 4. Now f dash x is equal to 0 at a turning point, so we need to let this equal to 0. Now we've got two terms. We've got the 2x plus the 4x minus 4 all over that quadratic. So what we need to do is equate it to 0 for the turning point, but then give this 2x a common denominator. So that will have to times by this denominator that's in the other term. And then we can say plus 4x minus 4 all over now the common denominator. Now, if that's to equal to 0, we can just cross multiply. The only way that that can equal to 0 if this numerator is equal to 0. So we can see multiplying that out, we're going to get 4x cubed minus 8x squared plus 10x plus 4x minus 4. So this is our cubic that needs to be written to find our a, b, c and d's. So we've got 4x cubed minus 8x squared. The 10 and the 4 will give us a 14x minus a 4. So a is equal to 4, b is minus 8, c is 14 and d is 4. Now we're not asked to go and solve that, it's just 4 marks for writing that. Okay, next one, it is given that y is equal to a to the x. A is positive, express x in terms of the ln of y and differentiate to find dy by dx. So this is how we differentiate y equals a to the x. When x is in the power, what can we use in order to bring that down? If we take ln's to both sides, then using the log law, that x can come down. ln of y is equal to x ln of a. Now a is a constant and it's just a constant times x. Now we can differentiate, but we'll differentiate implicitly because we've not got y the subject. So differentiating ln of y will go to 1 over y, but then when we're doing implicit differentiation, because it's not x, we must times by dy by dx equals to, now x times the ln of a is just going to behave like a 2x. The ln of a is just a constant. So what does a constant times x go to when we differentiate? Just the constant. So this is just going to be ln of a. Then cross multiplying, we're going to get that dy by dx is equal to y, the ln of a. And what was y in the question? Y was a to the x. So this is equal to a to the x, the ln of a. Next one, write this log expression as a single number. So using our log laws, that 2 can go up. We're going to get log to base 10 of 5 squared, which is 25, plus the half can go up, and we're going to have log 10 to 16 to the half, which is the square root of 16, which is 4. Then by our addition law, we can times the 25 and the 4. So this is log to base 10 of 100. And the answer to the log is the power. So remember the little pattern, 4 cubed is 64, can be written as log to base 4 of 64, which is equal to 3. So 4 cubed equals the 64. So this log expression that I've got is saying 10 to what power gives me 100. So log to base 10 of 100 is the power we need to raise 10 to get 100, which is equal to the single number 2. Here's the stats questions. We've got 2 questions on the normal distribution. We've got health centre claims that the doctor spends time with the patient, model normal distribution, mean 10 and standard deviation 4. So X is normally distributed with 10 and 4 squared. We're trying to find the probability that X is more than 15. So you just need to put that in your calculator. More than 15 means our lower limit needs to be 15. Your upper limit, I always just put something like 10,000, some randomly high number, and then your standard deviation is 4, your mean is 10, and then that probability on your calculator comes out to be 0.1056. Next one, we've got a health centre claiming that the dentist spends time with the patient is modelled with a normal distribution of this, and we're trying to find the probability that t is less than 2, and then this line means given that t is bigger than 0. So when we've got this conditional probability, the probability of A given B, we can use the formula as probability of A intersection B divided by the probability of B. Given that B's happened, we're restricted with what it's out of B happening. So applying that to this situation here, we've got the probability that T is less than 2, given that the probability T is bigger than 0, is going to be where do these two intersect? Where are we less than 2 but bigger than 0? That's going to be when we are in between 0 and 2, divided by the probability of what comes after the line, the probability that t is bigger than 0. So you need to put these in your calculators when we've got t sandwiched between 2 values. 0 is our lower limit, 2 is our upper limit. So if you put that in your calculator, that comes to 0.119119. Probability of being above 0 is 0.923436, and if you just divide them, the answer comes to 0.12899, which to 3 significant figures is 0.129. Onto the mechanics section, we've got this equation for speed, which is measured in second. Find the object's acceleration when t is equal to 2. The acceleration is the gradient of the speed time graph. So how do we find acceleration? We need to differentiate. So that is going to be 6t minus 5. Now all we need to do once we've got the acceleration equation is sub in t is equal to 2. So a is going to be 6 times 2, 12 minus 5, which is 7, and that will be meters per second squared. The next question is a bit more tricky. We've got a fixed point on a straight line. The particle is moving along a straight line, and at any t seconds, the distance it is away from where it started, O, is given by this equation. Now the distance it is away from it started is of course the displacement. Now we can see this displacement equation is cubic, so it's going to be this shape. So when we've been traveling upwards, we're traveling away from some origin. So at some time here, we'll be this far away from where we started. But because it's cubic, we're going to be coming back on ourselves towards where we started, and then we'll be coming back up as we get this maximum min of our cubic. So what we need to do is find when they are, because if they're in the first 4 seconds, we can find the displacement here, how far we are away, but then we'll have to see how far we travel back on ourselves, because in terms of distance traveled, we are going away from where we started, but then coming back. So we need to add on that distance there and then add on the next bit when we go away. So how do we find these max and mins? We need to differentiate. So ds by dt. So power down, cancel with that 3, we're just going to get t squared minus 5t plus 6. Now to find the max and min, we need to equate that to 0, and we'll factorize t and t, minus 3 and minus 2. So t is equal to 3, t is equal to 2. So if we draw our graph at t is equal to 2 and t is equal to 3, because it's a positive cubic, we're going to be going up, have our max, and then we're going to have our min, and then we're going to go away again. So t is equal to 4, and we need to find the distance travelled. So because from the beginning, from t equals 0 to t equals 2, that journey there, the displacement and how far we are from where we started, we just need to find the distance away, putting t equals 2 into our s equation. So when t is equal to 2, s comes out to be 14/3. But then when t is equal to 3, s is equal to 9/2. So that bit there is 9/2. So in terms of the distance travelled, we need to take them away from each other. We need to find vertically on the graph how far that is. And if you do 14/3 and take 9/2 away, that comes to a distance there of 1/6. But then we'll be this far away at t equals 3 from where we started, and we travel here. So if we do t equals 4 and get the displacement is then going to be 16/3. So what's vertically this journey going to be? We need to do 16/3 minus the 9/2. So if we put all those things together, then s is going to be the initial 14/3, which is where we get to in the first 2 seconds. Then when we're traveling back on ourselves, we've done that takeaway, so we need to add on 1/6. And then going this journey from the 9/2 to the 16/3, that is plus 5/6. If we add all them together, that comes to 17/3, which is 5.6 recurring, or 5.7 meters. Now, if you just think about when we've differentiated, when we differentiate, we've got the speed, which is going to be that quadratic. Now, if we plotted that, it goes through with our max and min at 3 and 2, that is going to be when we are drawing our quadratic curve. And when we're finding the distance, it's going to be the area under the curve. So we can see it's this distance, and this distance. So in terms of integrating, we'd have to find the 3 different areas. Ignore the fact that this has gone underneath because it's going to be negative. Ignore that that's negative, and then add these 3 absolute values of areas together, and that would be the same sum as what we've done here. Thanks so much for watching. Hopefully you found this video useful and helpful as you're preparing for Maths A Level. Do check out the channel, like and subscribe, and I will see you on the next one.